Today is 21st of April 2025. So, well, now linear regression part. If we say just there is from beta 0 to beta p, then we should we should do a we should find partial derivative of every one, and then we will do partial derivative. Then what we can get is basically metric form. We can also think of metric forms partial derivative. And what we can get is beta hat equals to x transpose x minus 1 x transpose y. And what we can do is we can get vector En, which will be a vector E, which will be sigma yi to y I had pairs. That what we should actually minimize. So we can get if we form it, we can get minimized value. And what we should also notice is this is SSE, which is E transpose E, and there's also SSR, which means di sigma of di square. We can write it as yi hat minus y bar square sigma. And if we sum up the SSE and SSR, it will be SST, which is di hat square, which is deviation of estimate output from average output. So SST will be yi minus y bar square. And we can do some test, which is first will be test of model significance. We will say null hypothesis will be beta 1 to beta p, which everything is 0. The statistic is MSR over MSE. So MSR and MSE is, we will think of degree of freedom of SSR and SSE. If we think of the degree of freedom, then we should ask what's the degree of freedom of SSR and SSE. Let's see what is the degree of freedom of SSR and SSE. And for F distribution, you should check both of the distribution's freedom. So if we consider that one, we can solve the problem. And also there is test concerning regression coefficient, which is each of beta 0 is 0 or not. In this situation, test statistic will be Pj, which is Bj's hat over standard error of Bj hat. How can you get it? You can get it by solving the x transpose x inverse equation. And in this case, you should see T distribution table. It will be one side is alpha and other side is degree of freedom. And you should also consider that if it is each side, then each of the sides is alpha over 2. So you should divide alpha. If given alpha is 0.5, you should divide it first to 0.025. And you can also check the goodness of the fit. You can get goodness of the fit by calculating R square. R square is same with correlation coefficient R in one-dimensional case. If it goes to multi-dimensional case, it is basically different, but you can get it if it is first dimensional. And there's adjusted R square, which is considering the degree of freedom. In this case, your degree of freedom will be SSE is n minus p minus 1, and SST is n minus 1 is degree of freedom. So each of SSE and SST, you will divide it by n minus p minus 1 and n minus p n minus 1. And for relationship between input variables, you should check correlations. If it is highly correlated, it will not make a good result. And also covariance and correlationship, they have relation with each other. And when you calculate beta hat, it is x transpose x minus 1, x transpose y. When you calculate the variance of beta j hat, if you solve it, then you will get MSE over m minus 1 multiplied by XC square XJ over 1 over 1 minus RJ square. 1 over 1 minus RJ square is VIF term, which is if RI square is super high, then VIF will be goes to infinity. Then it stands for multicollinearity is super high, which means you should remove some input variables. And there's QQ plot, which is a theoretical quantile and data quantile. So if it is on linear y equals x, then which means it follows the normal distribution. And also there is residual and constant variance. If it is have same with each other, that which means it's unbiased. So when you see the models, you should calculate before learning, you should calculate linearity and multicollinearity. And after that, you should calculate normality with QQ plot and homoscedasticity, which is residuals and variance, and also significance of model by T statistics, and also goodness of fit with R square or adjusted R square. That's what you need to calculate. Okay, if I see my note, this is R square. This is T distribution table. You should see it. And this is variance, how you calculate variance, covariance. And for variance, there is sample variance, and variance has different formula, and also sample correlation and correlation has different formula. You should remember it. And also, now we will solve classification problem. We will use logistic regression. Logistic regression will be basically, we will learn logistic regression and likelihood function, maximum likelihood, and logistic regression use odd function as link function. We will learn about it. And also we will talk about knife-based classifier. Knife-based classifier, basic format is basically P CK bar X, which is CK X will be observation and CK will be probability. And based on X observation, we can define it by category. We can use Bernoulli or categorical or multinomial naive base. We'll talk about it later. Actually, I already explained it in previous video, so we will go with specific formulas next time. Thank you.